Okay, third graders, we're on our third lesson for this week. This is the last lesson you'll need to do this week. We're going to be doing Module 4, Lesson 4, and we're going to be multiplying with 7. So we're going to be using the number 7 and multiplying with 7s. So after this lesson is done, you're going to be able to use several multiplication strategies to multiply with the number 7. So Carlos plans to practice guitar every day for 6 weeks. There are 7 days in a week. How many days does Carlos plan to practice guitar? So let's look back at the problem again so we can figure out what we need to be doing. So we know that he plans to practice guitar every day, every single day, for 6 weeks. And we know that there are 7 days in each week. So how many days does Carlos plan to practice guitar? So we know we're going to need to multiply 6 times 7 to get our answer, right? We know every single day for 7 days he wants to practice, or every single day for 6 weeks he wants to practice, right? He wants to practice every day. And he's going to do it for 6 weeks. So we need to figure out how many days he wants to practice. So one way we could do this is to draw an array. We know that there are 6 weeks that he's practicing, and there are 7 days in a week. So one way, because it wants us to show more than one way, 1, 2, 3, 4, 5, 6, right? We know we would have 6 rows, and then we need 7 in each row. 1, 2, 3, 4, 5, 6, 7. And I'm just going to fill in the rest of my array. So I need to make sure that I have my 6 rows and that there are 7 in each row. Now I could go about counting all of these, and yes, that would give me my answer, right? But that takes some time. And we've learned some different strategies in the last couple of lessons to figure this problem out. And one strategy we learned was we could break this apart into something that we know, right? Something that might be a little easier for us to solve. So what if I drew a horizontal line? If I draw a horizontal line, that means I have split my array into 2 equal parts because I have now 3 rows of 7, and then down here I have 3 rows of 7. So each part of my array is 3 rows of 7. So that means my top part of my array is 3 times a 7, and the bottom part of my array is 3 times a 7. So now it makes it a little more manageable, right? Because once I find out what each part of my array is, I can take those pieces and add them together to find out what 6 times 7 is. So I have 3, 6, 9, 12, 15, 18, 21. So I have 3 times 7 equals 21. So if this 3 times 7 equals 21, won't this 3 times 7 equal 21? Right, 3 times 7 will always equal 21. So now I just need to take my answers, my products, and I'm going to add them together. 21 plus 21. 1 plus 1 equals 2. 2 plus 2 equals 4. So 6 times 7 equals 42. So he is going to plan to practice for 42 days. Now that's just one way, and they wanted us to show more than one way we could solve this problem. Well, let's think about some of the other ways that we solved the problem the last time. Couldn't we take our 6 times our 7, and couldn't we make our 7 and we could break that apart? Couldn't I do 6 times, and I'm going to break apart my 7. If I break apart my 7, I could do 3 plus 4, right? Couldn't I break my 7 into a 3 and a 4? Then I just need to take my 6 and I need to multiply it by each piece. So 6 times 3 Oops. And then I'm going to add it to my 6 times my 4. So 6 times 3, so I have 6, 12, 18, plus, what's 6 times 4? Well, I know that 6 times 3 is 18, so I just need to add 6 more. 6 times 4 would be 24. So now I'm going to take my 24 plus my 18. 8 plus 4 is 12. Regroup my 1. 1 plus 2 is 3. Plus 1 is 4. Did I get the same answer? I sure did. So 6 times 7 equals 42. So he will practice for 42 days. All right. 96. Leah is making a calendar to show her activities for the month of February. This year, there are 4 weeks in February. How many days are in February? How can you make an array to show 4 rows of 7? Complete the array. So we're going to start with letter A. So we know that Leah's making a calendar to show the activities she's going to be doing for the month of February. This year, there are 4 weeks in February. So we've got our calendar started here. We can see that here's our weeks, right? There are 4 weeks in February. And how many days are in a week? There are 7 days in a week. 7 days per week. So now I just need to finish filling in the calendar. Because a calendar really is an array, right? A calendar looks like an array. Sometimes you have extra pieces along the top or the bottom, but for the most part, it is an array. So there are 4 weeks, and there are 7 days in each week. So our multiplication problem would be 4 times 7. Now they want us to draw a vertical line. So the vertical line, remember, goes up and down, is vertical. To break apart the array into 2 smaller arrays. Well, I think I'm going to draw my vertical line right here because it's going to create 2 numbers that are easier for me to solve. This side is now going to have 1, 2, 3, 4, 5. And this side will have 2. I broke apart my 7 into a 5 and a 2. So now I'm going to take and multiply each of these pieces by 4. I took my 7, I broke it apart and made it a 5 and a 2. Now I could take each piece and multiply it by 4. So 4 times 5, and then I need to do 4 times 2. 4 times 5. 5, 10, 15, 20. I need to count 4 5s. That's 20. Plus 4 times 2. 2, 4, 6, 8. Count by 2s 4 times, and I get 8. 20 plus 8 equals 28. So there are 28 days in February. So see how I broke apart that 7 into a 5 and a 2? 5 and a 2 is probably going to be the easiest way to break apart your 7 because counting by 5s and counting by 2s are going to be, those are numbers that you're used to counting by, right? You probably have counted by those since kindergarten, right? I remember when my son Nicholas was in kindergarten, he counted by 5s and he counted by 2s and he counted by 10s, right? Some of those are just the easier ones to count by. So now suppose Leah's calendar shows 6 weeks of activities. How many days does the calendar show? So how could we use a fact that we know? So she has now 6 weeks of activities. Remember, each week has 7 days in a week. So the problem we're going to be multiplying this time is 6 times 7. So let's start with a fact that we know, such as the 5s. Remember, like I just said, the 5s and the 2s are ones that we know. Those are the ones that we can do pretty quickly, right? So if I start with a fact I know, if I do 5 times 7, 5, 10, 15, 20, 25, 30, 35. 5 times 7 equals 35. Now I just need to get to 6 times 7. I just need 7 more. I just need to go just a little bit more, right? I got to my 35, and I'm almost there. Not quite, but I'm almost there. So 5 times 7 plus another 7, right? We need to get another 7 in here because we know that 5 times 7 is 35. So 35 plus 7, and I can do that over here on the side if you need to. 5 times 7, I hope you said 12. Regroup my 1. 1 plus 3 is 4. So 6 times 7 is 42. So the calendar shows 42 days. So that's another strategy you could use. So one strategy is to break apart your 7 into 2 pieces that you know and multiply, or multiply by something that you know, especially if you're close to it, and get there the rest of the way by adding another 7. All right, oops, my camera. All right, number 3. Mila plans to practice for a dance performance for 7 weeks. She will practice 5 days each week. How many days will Mila practice? You can change the order of the factors and the product is the same. So for example, if I write 7 times 5, it's the same as writing 5 times 7. You're going to get the same answer. And we've done problems like this already before. It doesn't matter the order you put them in, you're going to get the same answer when you multiply. So 5 times 7 equals 5, 10, 15, 20, 25, 30, 35. 5 times 7 equals 35. So that means that 7 times 5 equals 35. So Mila is going to practice for 35 days. It doesn't matter the order you put your multiplication problem in, you're going to get the same answer. Right? 5 times 7, 7 times 5. They both equal 35. Okay, let's do some checking for understanding. We're going to practice some multiplying by 7. Derek took 3 photographs each week for 7 weeks. How many photographs did Derek take? So our problem is 3 photographs every week for 7 weeks. So our multiplication problem is 3 times a 7. So I could take my 7, right? And I could break it apart, or I could count by 3 7 times, or count by 7 3 times. If I break apart my 7, I could do 3 times. I'm going to break apart my 7 into a 5 plus a 2. Remember, those 2 are going to be the easiest ones to solve. So then I would do 3 times 5, and I will add it to a 3 times a 2. 3 times 5, 3 times a 2. 3 times 5, 5, 10, 15. 3 times 2, 2, 4, 6. So 15 plus 6. 6 plus 5 is 30. Sorry, I was multiplying. 6 plus 5 is 11. You're going to think I'm crazy. 1 plus 1 is 2. So 3 times 7 is 21. All right, find the product. 7 times 2. So I can count by 2 7 times. 2, 4, 6, 8, 10, 12, 14. 7 times 2 is 14. 8 times 7. Well, I could break apart my 8 and it could become 2 4s, right? I could split that in half. So if I have that, then it would be 4 times 7 and a 4 times a 7. So 4 times 7. Well, we just found out what 7 times 2 was is 14. So I double this one. 14 and 14 is 28. So 28 plus 28, I'm going to write that over here. 8 plus 8 is 16. Regroup my 1. 2 plus 2 is 4, plus 1 is 56. So 8 times 7 is 56. Remember when we broke apart the 4s? And then the 4 we could break apart to the 2s, and that helped us, and then we doubled it. Remember, we did that quite a few lessons ago. Now, we just did this one, 7 times 6. Look at over here. 6 times 7, 7 times 6 is 42. And this is when you can start using those multiplication cards that I sent home. This is a perfect time to use them. Start practicing with them. It's just drilling them, right? This is really when you need to start memorizing these multiplication facts. So 3 times 7, look, we just did 3 times 7. 3 times 7 equals 21. Ooh, 5 times 7. 5 times 7. Use your resources, right? If you already did it, it's not cheating to look back because you already did it, so you can look back and check. Now remember, anything times 1, that's the identity, the property of the identity property. So 1 times 7 equals 7, because I only have one 7, right? One group of 7 is 7. 7 times 4. Did we do 7 times 4 yet? Oh, we did right here when we were trying to figure out 8 times 7. 7 times 4 or 4 times 7 is 28. 7 times 7. So this one we might, oh, look at, I've got 7 times 6 up here. I just need one more 7. So 7 times 7, if I'm at 7 times 6 is 42, I just need to add 7 to 42. What is 42 plus 7? 7 plus 2 is 9. 4 plus nothing is 4. So 7 times 7 is 49. 7 times 0. Ooh, there's that 0 property. Anything times 0 is 0. If I have 0 7s, I don't have anything. And then 7 times 9. Well, look at here. 7 times 8 is 56. I just need to add one more group of 7 to get to 7 times 9. So 56 plus 7. Let me rewrite that. 7 plus 6, 13. 1 plus 5, 6. So that would be 63. 7 times 9 is 63. Looks like my focus is off again. I'm going to lock it up again. Okay, next page. So we have Jana. Ooh, sorry, my camera's messed up again. She's placing 7 tiles in each row. She is going to make 6 rows. How many tiles will Jana place? So first we're going to complete the array to show the problem and then draw a vertical line to break apart the array into 2 smaller arrays. So she's got 7 tiles in each row and there are 6 rows. So we're going to finish filling in her array. All right, so I finished filling the array, and now I need to draw a vertical line. Remember, vertical is up and down. So a vertical line to break apart the array into 2 smaller arrays. Well, I'm going to break it apart here because I'm really good with my 5s and my 2s. I like my 5s and my 2s. And then we're multiplying them all, and then there's 6 on this side. So let's multiply. First we're going to have our 6 times our 5. And then we need to multiply our 6 times our 2. And we're going to add those 2 answers together. 6 times 5. 5, 10, 15, 20, 25, 30. Plus our 6 times our 2. 2, 4, 6, 8, 10, 12. 30 plus 12. 0 plus 2 is 2. 3 plus 1 is 4. So Jana will place 42 tiles. All right, now we're going to complete the equations using the commutative property. So we have 7 times 3. It can also be, remember we can switch these numbers around. That's what the commutative property is. When I take and I just flip-flop my numbers. So 7 times 3 can also be 3 times 7. 3 times 7 equals, so we've got 3, 6, 9, 12, 15, 18, 21. So 7 times 3 equals 21. If 3 times 7 equals 21, 7 times 3 equals 21. It doesn't matter the order. When you are multiplying, you're going to get the same answer. 7 times 5 equals blank. So that means that 5 times 7, 5, 10, 15, 20, 25, 30, 35. So if 5 times 7 equals 35, 7 times 5 equals 35. Now we've done some of these on the other page. 8 times 7. If I look back, 8 times 7 equals 56. 10 times 7. Well, let's just count by 10 7 times. 10, 20, 30, 40, 50, 60, 70. 7 times 4. Well, look up here. I just did 3 times 7. 3 times 7 is 21. I just need to add 7 more to that. What's 21 plus 7? I hope you got 28. 5 times 7. Ooh, look at, I just did that over here. 5 times 7, 35. 9 times 7. Well, I did 8 times 7, didn't I? 8 times 7 is 56. 56 plus another 7. 7 plus 6. 13. 5 plus 1, 6. So 9 times 7 is 63. 7 times 7. Well, we did up here 6 times 7, right? We did 7 tiles in each row with 6 rows. That was 6 times 7. 6 times 7 was 42. So 42 plus another 7. 7 plus 2 is 9. And then 4, 49. 7 times 3, ooh, look, I just did that up here. 7 times 3 is 21. 0 times 7, anything times 0 is 0. 6 times 7, just did it up here. 6 times 7, we found out was 42. And then 7 times 2, 2, 4, 6, 8, 10, 12, 14. So I want you to do the black and white worksheet that goes along with Module 4, Lesson 4. So it will be 4.4. When you are finished, please either bring it into school or take pictures of it and send it to me so that way I can look it over and grade it. And I hope you have a great rest of your week. This is the last math lesson for this week. And then we'll pick up again next week. All right. Have a great rest of your day and rest of your week, and I will see you soon. Bye.